This is grade 11, Euclidean geometry. So just before I start this, in the textbook, you will find a lot of theorems. So I would encourage you just to write all the theorems down or keep it separately, because we're going to use all of that theorems when we're going to do the answers. So I will explain what theorems we use and how we can use it, but the detail of the theorem, unfortunately, you'll have to look in your textbook. Okay, so we have the circle over here. Then we have, it's going to do different colors, this line AO and this line BC. So that is parallel to each other. Then we have O, this here, that is your middle point. And then you have this green line here, that's a tangent. So a tangent just is something, if you have a circle and you have any line that touches the circle, then you call it a tangent. So any line that touches, you call it tangent. And there's, like I mentioned, there's a lot of definitions in the textbook regarding tangents. So we're going to use one of that now. So I just get rid of this. So if you look at this sum over here, they ask the question, determine with reasons the size of A. So we have to find this size over here. So if you start with this, the first question that we have to ask ourselves is, what do we have? So usually before I even do the sum, I just look at the sum and ask myself, what do we have? And then from there, I will determine what to do. So the red, like I mentioned, that's two parallel lines. So that's parallel to each other. And they are linked with this red line over here. So here you can see you have something like this called a Z. And there's a lot of definitions for parallel lines like this. Let me just draw it neater. So you have something like this. If you have this, then this angle over here equals that angle over there. There's another definition for parallel lines that looks like this, where this angle over here equals that angle. Let's make that x equals x, that y equals y. So there's a lot of different definitions like that. So let's come back to this one over here. So if you look at this sum, it looks like a Z, the red part, and it looks very similar to it, just with a bit darker, like this over here. So that means this angle and that angle is the same. So if you look at the sum, there we have B2, which equals 55. And if you look at the Z's of this, that angle over there is also going to be equal to 55. So we can you just put that with a red color. So that is also 55 because of this rule over here. Okay, so now we have that angle. So the approach I'm going to take is, this is a triangle. And a triangle, if it looks like this, if you have two sides to the triangle, then you can determine the third side, because three sides of a triangle equals 180. So my aim now is to see, can I get two angles? Because if I can get it, then I can determine the third one. So we already have this 55 degrees over there. My hope now is to see, can we get that B1? Now, yes, we can. So like I mentioned earlier, we're going to use a definition of a tangent. So one of the definitions of a tangent is, if you have a circle and you have a tangent and you have a middle point, and where that middle point basically crosses the tangent, where the middle point touches the tangent, that angle is 90 degrees. Let me just draw it, maybe another one. If we have maybe this tangent over there, and we have from the middle point to that point where the line touches the tangent, then this angles will be 90 degrees. Let's do another one, maybe with that. So that point over there, if you connect the middle point to that point, then that angle will be 90 degrees. That's just one of the rules of maths. And like I mentioned, one of the theorems. So let's come to this sum over here. There's a middle point. Here's this green tangent over here. I'm just going to extend it. So a tangent always touches the circle. And it looks like this line is exactly on this point over here. So then we can say that this will be 90 degrees. And the correct definition that we use, we say, so I'm just going to put here, B1 equals 90 degrees. And the reason for that is because a radius is always perpendicular to a tangent. So the radius is this line over here from the middle point to the end of the circle. That's a radius, and it's perpendicular to a tangent. That's why that is 90 degrees. Now it's very easy. We have this 55 degrees. We have this 90. We're looking for A, and now it's just basic maths where we say A plus 55 plus 90 equals 180. Then A equals 180 minus 90 minus 55. I'm just taking everything to the other side. So 180 minus 90 is 90. 90 minus 55, what's that? 35. Just check, yes. So that means this angle here equals 35 degrees. If you didn't look at the grade 8, there's some geometry videos for triangles. So, and for straight lines. So if you haven't looked at that yet and you're unfamiliar with how to calculate the insides of a triangle and how to work out straight lines, please look at my grade 8 videos. So there we have it. That's the answer for this one. Let's go to the second question. So we have the circle, and then we have two tangents. So I'm going to draw the one tangent green and the other tangent blue. So again, like I mentioned, if we hear the word tangent, what I usually do, if I just hear the word tangent, then I must know there's some theorems that I must apply, and that theorems will guide me to the answer, to the word. So we have here tangents, we have circles. So already I know a circle, there's maybe some rules and theorems for circles. So before we start with the question, we must just ask ourselves, okay, what do we need for tangents and circles? So let's see, what do we have here? So the question say, in the following sketch, PA and PB are tangents. So this is PA, the green one, the shorter green one, and there's PB. And they say they are tangent at the circle at A and B. So the green tangent meet the circle at A, and the blue tangent meet the circle at B. And they say APB equals 36. So is that this 36 over here? Okay, so we have this. So, and the question is to determine A2, this yellow part over here. So that is what we need to get. So, okay, so what I usually do, I start from the back. I say, okay, we need A2, but if we would have had A1, it would help, because then we could have had or used something like this. So this is A1 over there. So if we have A1, let me just do it differently. So I just took this part over here, and I just drew it there. So if we have A1, this one, then we can get that one, because A1 equals A2. That's the opposite side. So that's one of the rules. So I'm going to leave A2 for now. And I'm going to leave that one. I'm going to concentrate on A1 to see if there's a way that I can get A1. So another rule for tangents, if you have a circle and you have two tangents that starts from the same point. So if you start from this point and you go one direction, and you start from the same point and you go another direction, if both of them are tangents, which means they touch the circle, then from this point to that point will equal this one to that one. So the two, this two arrows here will equal each other. So that means this line over there will equal the blue line, just up to this dot over here. The dot is where they meet the tangent. So looking at this diagram, we have the tangent, we have the blue tangent, and they both start from P. So that means PA equals PB. And the reasons are they tangents from the same point. I'm going to put here the tangents from the same point. So that's the reason you put in. And so now we know, okay, this here equals PB. And now another rule in maths, I'm just going to wipe this out. Another rule in maths, if you have a triangle, and this I will share it in my triangle videos for grade 8. If you have a triangle, so this is actually the P and the A and the B. I just took this part now to there. So if you have this triangle and these two lines are the same, then it means if this is X, then that is X. So now we are already at some point that we can use. So let's make A1 X, make B, or this one here also X. And now we have the insides of the triangle. Let's make some space here. Now we have the insides of the triangle where we have, and we're going to use, say, 36 plus, to put it X, plus another X equals 180. So now we have that. And then we say 36 plus 2x equals 180. 2x equals 180 minus 36. That answer is 144. And then x will equal 72. So one of the x's is 72. That means that is 72. And this one is 72. But now, because A1 is 72, we use the opposites rule, and therefore A2 is also 72 degrees. And that's the only answer that they need. Thank you. All right, let's go to the next example. So here we have a circle with two tangents. So we have this green one here, AB. Oops. This green one here, AB. And then we have another one called CD. So let's do the CD here. This is here at the bottom. I just like to draw with different colors so that we can understand the different tangents. So, and then we have C1 equals 30. So that C1 equals 30 is, let's highlight it there, is this part over here. So that is 30 degrees. And they say D equals 44. The D equals 44 is that part. Like I mentioned, before I start, I always like to think of my approach to see what do I have and what don't I have. So I can already see I have, now I haven't looked at the question yet, but I'm just starting to go through the motions. Here I have a triangle. Let's just try to highlight this triangle here, this one here. This triangle have two angles and one outstanding one called E1. So that's E1. And if you do the maths, then E1 will equal 180 minus 30 minus 44. So 180 minus 30 is 150 minus 44. That answer is 106. So this E1 over there, that is 106. That's just the insides of a triangle. So that is what I've used. And if you look at my other videos, you'll see this is a straight line. And if you have a straight line with a line there, and you have this angle, which is 106, then the other one will be 180 minus 106. So the 180 minus 106, that will give 74. So now we already have the 74. We didn't even look at the questions yet, but as you can see, we are already starting to fill in a couple of things. So at this stage, I don't see anything further that we can do. But again, keep in mind, we're working with tangents here. And if you work with tangents, then there's a couple of rules that we have to remember. Let's see what rules we can use here. So on the right-hand side over here, I drew something, and we're going to use this rule now. So this rule just say, if you have a circle and you have any chord inside the circle, and some of them connects with this tangent over here, then there's a theorem that say, if this is a tangent and this is a chord, then this angle x will equal that angle x. So that's just something that you have to remember. We're going to identify it now in our question. And the same one, if you have this tangent with this chord over here, let's just draw this chord red, then the angle y over here will equals that angle y. So let's just do it again. If you have the tangent, which is blue, and you have this chord, the green one, then it means this angle x equals that angle x. That's just a rule in maths. And in the textbook, the theorems will actually prove why it is this way. The questions I do is just to use the theorems to get to the answers. And there's another one, if this is a chord, then and between the angle between this chord and this tangent, angle y will equal the opposite angle, which is y. So just remember this, try to write it down, or look at your textbook, see what they have, and then let's see how we can use that in the sum below, in the question. So what do they actually want? Determine with reasons the size of B1 and B2. So B1, where's B1? There's B1 and there's B2. Okay, so that's the two that they want. So now let's see if we can use this over here in the sum. So we have this angle, we have this tangent. Can we use this tangent? So we have, I'm just looking what we can use. We have, here's a chord. Okay, so here's a tangent. I'm just going to highlight it blue. And here's this chord over here, the yellow one. And as you can see, this 30 degrees over here looks very similar to this x over here. It's between the tangent, the blue tangent, and this chord. And if we use this theorem, then we say, if this is the chord, then we take that opposite angle. That means that B1 will also be 30. And the rule that we put down, we just say, you're gonna write it now. We just say B1 equals 30, and the rule is just tangent chord theorem. That's the only thing we need to write next to it. So I always write it next to it. I just don't have space now. So, and the tangent chord theorem is this here that we did, that we're showing. So, okay, so now we have B1. The second one that they want is B2. So let's see if we can use B2, or what can we use? So let me just think about it. Okay, so I see we have, so we already actually worked out this E2 over here, which is 74. So we already worked it out before we knew we're going to use it. So we have that. And just keep in mind, we've used this blue tangent at the bottom, but we didn't use the green tangent yet. And if they say in the sum that AB is a tangent, then we must just try to know that we're going to use it somewhere. So right now we're going to use it. we're actually looking for this B2 over here. But here we have this tangent, and let's use the same theorem. And I'm just going to draw it like this. So I'm going to draw this BC. I'm going to use this chord over here because the opposite angle of that chord is that 74 degrees. So that's the opposite. So if you start with the opposite, with the 74, then you can also ask yourself which chord is opposite to that, and that's the red chord that I drew here. And now we have this red chord, we have this green tangent, and the angle between them is B2, and that is the one that we want. And that will also be equal to 74 with the same tangent chord theorem. So B2 equals 74, and we use the same definition, and that's the end of the sum. So let me just highlight again. What we want to look at is a tangent and a chord. So for this one, we use this tangent and this chord, and the opposite angle of this yellow chord over here was the 30 degrees. And therefore, if we use this tangent chord theorem, then the angle between the chord and the tangent will equal the opposite angle. That's why this C1, which was 30 degrees, is between the blue tangent and the yellow chord, and the opposite angle is the 30 degrees. We already worked out the 74, and now we've used this green tangent over there. Green tangent together with this red chord gives us an angle B2 in between it. But if we extend this B2, like this theorem say over here, the angle between the tangent and the chord equals the opposite angle. Therefore, we could say this B2 equal the opposite angle, which is this E2 equals 74. Don't forget always to write the reasons for the tangent chord theorem, because the teachers and the way they mark, they will just have to see, did you use a theorem to get to the answer? So that is that one. Here we just have a couple of circles, couple of letters that we have to work out. There's A, B, C, D, and E. And we're going to use the same theorem that we used earlier, the tangent chord theorem. So just please have a look at that. So we're just going to use this theorem over here. So in each of the sketches, we're going to identify a tangent and a chord and see if we can identify the opposite angle. So yeah, so let's see what we can get. So if they give, okay, for here they say O is a middle point. So if O is a middle point, one of the rules is if you have a line, a radius from the middle point. So let's just do this in blue. So this here, a radius from the middle point that touches a tangent, then this both angles are 90 degrees. So this A equals 90 degrees, and just the theorems is just the tangent chord theorem, or just look at a radius perpendicular to, so I would write this here, radius perpendicular to tangent. And there's various different ways you can write it, but just ensure you write the correct answer. Why? Because usually they'll give one mark for this and another mark for that. So don't forget the reasons. Okay, so let's do B and C. So now we're going to use that tangent chord theorem of the previous sum. So here's a tangent. Let's see if we can identify a chord. So we want this B over here. This B is connected to that chord, or let me put it another way. this B is between the blue tangent and the green chord. So if we just look at the opposite angle, it looks like that 53 over there. So B is 53. Then C, let me see. So we have this tangent over there. And just see what we can do. We have that tangent. Yes, we have this yellow chord. So we have the yellow chord and this red tangent with this 62 in the middle between them. And 62, if you look at it, the opposite angle is the C, and that's why the C over here is also equal to 62. So again, you just have to identify the tangents, the red one here, and the chord, and use that to determine the opposite angle. That's why I always use the colors, just to make it easier for me to stand out. Otherwise, it will be very difficult in a sum. I find it difficult to look at the sum and determine the answers from there without colors. That's why I always use colors. Okay, let's go to this one over here to determine D. This is exactly the same. We have a tangent here, and we have, let's call it this green chord. So just look careful. This 123 is between the blue tangent and the green chord. And the opposite angle, so I just move to the end of the triangle, which is the D, and that means the D will equal 123. So I just want to just explain here separately in this corner over here. So if you have just again the triangle that is inside a circle, and you have a chord, then you look at that angle over there, and then you just go to the opposite angle of the triangle. Not that one, and not that one, because this one's here is still part of this chord. That's why we're not using this one. We're using the opposite angle. Now just see at least if you can identify it with all the sums that we did, because then it will be much easier for you. Use the different colors like I did and see if you can identify it. Okay, let's do the last one. This one over here we need. So like the previous sum we had two tangents. So this tangent over there, we have this tangent. And if you have a tangent, two tangents that meets the circle, let's call this Q, that meets the circle at point Q and point R, and they form a triangle, then this PQ equals PR. This is similar to one of the previous questions. And if the green line equals the blue, then we have this triangle where this equals that. And then if this is X, and then that angle is also X. And you call it isosceles triangle. Then the two angles at the bottom is the same. So in this case over here, if this is 63, then E will also be 63. Thank you very much. I'm going to conclude this now. And so this is also just part one. I'll make another video with maybe more circles and tangents, etc. And I will name this one part one, and the other one, if you want to look at it, I will name it part two. Thank you very much.